Right, the first one, y to the power 3 times y to the power 3 plus y squared times y to the power 4. Okay, so yesterday we said very important, keep in mind BODMAS. Right? So between the multiplication and the addition, which one was more important? Multiplication. So you'll see I underlined the first, how what is bottom? The first two and the last two. So if you look at the first two, y to the power 3 times y to the power 3. Yesterday we spoke about exponent rules. When base is the same and we multiply, what do we do with exponents? Add. So that's why I have y to the power of 6. Right, then plus. Now these last two, same thing. Base is the same and we're multiplying, so I'm going to add the two exponents, and that's how I end up with y to the power of 6. Now, can you see that these two are like terms because the variable is the same? Now, what's written in front of both of them is actually 1, right? So 1 y to the power of 6 plus 1 y to the power of 6 will give me 2 y to the power of 6. Okay, then at C, you'll see I gave you two options. The left-hand side, let's talk about that first. I know some of you like writing the division in terms of a fraction. Now, when I do that, because you saw that both of them had to the power of n, I could say, put the 16 over 2 in a bracket and then say to the power of n. Now, this bracket can be simplified. 16 divided by 2 will give me 8. And can you see the n stays the same?
Yes.
Right. Now, let's look at the right-hand side. Sorry, I just want to quickly add there. Over here, why could I not have cancelled out from there? Because of those exponents. No, I can't just cancel out the 16 and the 2 with each other and then cancel out the ends because then there's no more exponent left. No? So we first had to take it out like we did over here. No? Okay, let's look at the second option. Let's say that I wanted to make base the same and then divide. Then it means that the 16 to the power of n I had to change. Now my clue was base here is 2. So I also want base of 2 on the left-hand side. Now 16 is the same as 2 to the power of 4. And then that becomes 2 to the power of 4n. Who doesn't understand that part? Okay, then because base is the same and we're dividing, what do we do with exponents? We subtract. So I'm going to stay with a base of 2 and then say 4n minus n. And that gives me 2 to the power of 3n. Now you'll notice that the answer on the left and the answer on the right is slightly different. Right? But remember, 8 is the same as 2 to the power 3 and then still that n. Okay, so what's on the left and what's on the right is actually the same thing. Right, can I skip? Okay, at E, over here, I first changed my base over there. Now 9 is the same as 3 to the power of 2, and that would then be to the power of x, so that's why it becomes 3 to the power of 2x. You guys good with that?
Yes.
Then anything to the power of 0 will be 1. Okay, then if I look at division and multiplication, they're actually almost on the same level. So what do we do when we've got both of those in an equation? We go from left to right. Okay, so if I took those first two, 3 to the power of 2x divided by 3 to the power of 2x, you'll see I wrote it in the form of a fraction. And then it's actually still times 1, but do I have to write it? No, because it's not going to change anything. Now, when I've got the same thing at the top and the bottom, it would be equal to 1. It's like saying 5 over 5. No. Yes, it cancels out, but it doesn't mean that there's nothing left. No, it's still 1. Okay, let's look at 2a. Over here, I had multiplication throughout. So the first thing that I did, so there was no specific thing that I had to do first. No? Okay, so the first thing I did is that a to the power of 0, I made 1. So 4 times 1 would still just be 4. Okay, now I can take it from left to right. So 2 times 3 gave me 6, times 4 gave me 24, and then a to the power of 3 times a to the power of minus 3. Have a look, base is the same, and we're multiplying, so what do? It's actually 24a to the power of 3 plus minus 3. No. But what's going to happen over there? That's going to become a minus. And what's 3 minus 3? 0. So that's why I have 24a to the power of 0. And then a to the power of 0 is just 1. 24 times 1 is 24.
Ma'am, you see, ma'am, by the second, the first step, ma'am.
This one.
Yes, ma'am.
Yeah.
Ma'am, we did that a to the power of 0.
Okay. We said just now that is, ooh, cooks. That is actually 1. So it actually looks like this. 4 times 1. But 4 times 1 is still just 4. So that's why I just left it out. Okay. Any other questions here? Can I skip? Right. At C. You'll see in my first step that 0,04 I changed to a fraction, saying that is the same as 4 over 100. Okay, now yes, you guys could have used your calculator, and then you would have gotten 0,02, which is still the same thing, but they said using exponent rules. So in the test, we would sometimes say without the use of a calculator. So then you would be forced to use this method. Okay, so I changed that to 4 over 100. The rest stayed the same. Now, that square root applies to everything inside the root. So square root of 4 was 10. Square root of 100 was, square root of 4 was 2. Square root of 100 is 10. Then, square root of a to the power 4. We spoke about this yesterday. Have a look. When there's nothing written here, there's actually a 2, yes. And then we said we take inside divided by outside, so 4 divided by 2, and that's how I got a to the power of 2. You guys good with that? Yeah.
I see it's fine if you wrote 0,2.
I just said, yeah. Okay, 0,02. Yeah. Okay, then that b, we said square root of b squared. Remember the square and the square root basically cancels each other out. So that's why I only have b. You guys good with that? Okay. Now, if you used your calculator, you would have skipped directly to 1 over 5. But all I did is that 2 over 10 would simplify to 1 over 5, meaning 0,02. Okay. I'm lying, 0,2, sorry. You guys good with that?
Yes, ma'am.
Okay, E. Remember that 3 applies to everything inside. So 3 to the power 3 gave me the 27. A to the power 3, and then B to the power of 2 to the power of 3. What do we do with those exponents if I've got a power to the power? Multiply. So that's why it becomes B to the power of 6. Right, then the next one, I just had to multiply into that bracket, but remember not just the 4ab, but minus 4ab had to be multiplied in. So minus 4 times 6 gave me the minus 24. A times a squared gave me a to the power 3. And b times b to the power 5 gave me b to the power 6. Now you will see that the variables are exactly the same. So they are like terms. So I can go and subtract. So 27 of those minus 24 would give me 3, a to the power 3, b to the power 6. Can I skip? Right, 3a. Yeah, it was pretty straightforward. So quickly have a look at A, C, and E. Any questions at A or C? Okay, I quickly want to speak about E. Please remember that I cannot get square root of each of these terms separately, and then go and add the answers. Why not? Because I'm only allowed to get square root of that if it's one term inside the root. So what I had to see is that these are like terms. So I'm first going to add them. That gives me 9y to the power 4. And now I can get square root of that. Okay. So don't let me catch you in the test. Yes. Yeah. Yeah. These two. No. Remember? Because it was addition, because we were just adding, no? We look for like terms, and when we add or subtract, the variable stays the same. It only changes when we multiply or divide. Okay. Remember we spoke about like 4 bananas plus 5 bananas will not be 9 apples all of a sudden. No? It stays banana. Okay. Right, can I skip? Okay, there's 4, A, C, and E. Now over here we had to do FOIL, so it's slightly more complicated. Let me go through them. So first, A times A gives me A squared. Then outer, so A times square root minus square root B would give me minus A square root B. Then inner, these two, so that would give me positive A square root B. And our square root B times negative square root B would give me negative, and have a look, square root B squared. Okay, if you didn't have the brackets there, it's fine, it's not a train smash. But what I want you to see is that that square and this square root, those are opposites, right? So it's basically just going to end up being B. Okay, right. And then these middle two, can you see that they look exactly the same?
Yes,
No, so they are like terms. Okay, so minus A square root B plus A square root B would give me nothing. A square root B. Okay, so it's just A squared minus B left. Okay, then at C, over here you'll see that the first two I just wrote in the form of a fraction. Then this last one, I can't get square root of 20, no, without having a remainder. So what we're going to do is we first simplify within that root. So 5 will go into itself once, and 5 will go into 20 4 times. Then A cancels out with one of those A's at the top, so I'm going to have A squared left. Okay, so let me just rewrite that on the side here. So what we actually have left in that fraction over here is 4A squared. Okay, now we'll talk about that just now. The fraction, what we can cancel out there, the 12 over 4 becomes 3. A to the power 3 cancels out with 3 of those at the top. So what is left? A to the power of 2. And then the b's cancels out. Okay, so does everyone understand how I got the 3a squared? Okay, now we get square root of 4a squared, and that will just be 2a. And then finally, I could not go and add these two because they're not like terms. Eh? This one has got a squared, and that only has a. Right. Any questions? Then the last one is very similar to a. So we use FOIL. So I'm going to start with first. So 3a times 3a gives me 9a squared. Outer, so 3a times minus square root a. That gives me minus 3a square root a. Then inner terms gives me positive 3a square root a. And then last gives me minus, and have a look, square root a squared. Again, those are going to cancel each other out. Right. Okay. So I still have 9a squared. These two are like terms, so there's nothing going to be left there. And then this square root and the square means that I only have a left. Okay, any questions? Can I skip? Right, there we go, 5a. That was pretty straightforward. I just had to go and simplify within my square root, and then I could get square root of the 9a squared. At C, what you guys might have found difficult is that I first had to go and write as an improper fraction. No. So that gave me 9 over 4. And now that we can see, it's easy to get square root of 9 and square root of 4. Right. So I have 3 over 2, x to the power of 4. Over here, cube root of this would give me x to the power of 4 over 2. And no, have a look. What's actually written in front of this x to the power of 4 is a 1. So can you see how I just wrote that as a half x to the power of 4? Does it make sense? Okay, because now it's easier to see that these are actually like terms. Have a look. Hey, So 3 over 2 plus a half would give me 2. And we said just now, variable stays the same. So 2, oh, sorry, not as x squared. Sorry, x to the power 4. Sorry. 2x to the power of 4. Julle bly doodstil, nee. Okay, can I skip? What's wrong? This one? You want to know how I got the 9 over 4? Okay. So they initially gave me 2 1/4 x to the power of 8, no? Now if I say 2 times 4 gives me 8, plus that 1 gives me 9 over 4 x to the power of 8. Does that now make sense?
And the 9 over 4x to the power of 8.
Yeah?
If it cancels out, isn't the exponent supposed to be 6?
Remember, we take inside divided by outside. So 8 divided by the 2. Okay, Chloe? There's actually a 2 written here. No? So I'm going to take 8 divided by the 2. And that's how I get the x to the power 4. Okay. Anyone else? Okay, can I skip? Okay, so in the first square root, I cancelled out. That 27 over 3 is the same as 9. So I made that 9. Ooh, well. It's okay. So I made that 9x to the power 4. Then the second one, I already got the cube root of it. So cube root of x to the power of 6 will be x to the power of 2. Cube root of 27 will be 3. Now this fraction, I can't get square root of x to the power of 5. No, because then you're left with the fraction as your exponent. And you guys don't like that. So let's cancel out first. Can you see that this x can cancel out with one of them? So that's why I have x to the power of 4. That's the second step. Okay, so now I can get square root of 9x to the power of 4. And I can get square root of x to the power of 4. Have a look what I did here. Same as the previous one. I made it a third x to the power of 2. Do you guys see? Why did I do that? Because now you guys can easily see that they're all like terms. Have a look. They all have x to the power of 2. What's written in front of this x? A 1. Okay, so 3 plus a third would give me 3 1/3 x squared. Minus 1x squared would give me 2 1/3 x squared. Okay. Any questions? Yeah. You could. 7 over 3 x to the power of 2. Okay, same thing. Any other questions? Okay, right. Now, people, you can write at the top of your page, factorizing. Can I skip? Anyone still copying here? Okay. Bye. Yeah. Oh, did you not finish that? Okay, that would be the 36 bracket. I'll skip back. No. Right. So, at factorizing, we have 3 different methods that we factorize. Okay, so we're going to do one at a time, but I'm going to make you guys write that down. So the first one is common factor. Right? The second one is difference in 2 squares. And then the third one is trinomials. Sorry? Yeah, it's the echo. Okay, rustig. Okay, so those are the 3 methods of factorizing that you guys are going to be taught this year. So I want to start with the first one, common factor. If we have something in common, it means we have the same thing that we like, or in a sense, we look the same. Something is the same. No. Okay, so in a common factor, there will be one thing that is the same for every single term in that expression. Okay, so I want to start with showing you guys a slideshow. Because you're going to ask you to hand out. Just look at how the papers are put down. So this, yeah, yoke. So it doesn't work out like that. So 2 pages per person. So 2, and then next person 2. Okay. Yeah. People, when you get your notes, just make sure that it's numbered from 1 to 3 at the bottom right-hand side. Okay? I'm going to go to the slideshow.